All right, welcome to part two of this quadratics unit. I know the packet's still part one, it's part one of the packet, but for my students, but this is part two video. So I'm going to go a little bit more quickly through the factoring parts because part one went through all of the factoring, how to factor. And so I'm going to go a little bit quicker. And then when we get to the parts that are new, I'll slow down and explain those in a little more depth. Okay, so now we're solving. So these are no longer expressions, right? In the last part, these were all expressions. Now they're equal to zero, and you want them to be equal to zero. So if you have a quadratic problem and it's asking you to solve for or solve the quadratic, and if it's not set equal to zero, you need to get it set equal to zero. You need it to be in standard form, ax plus bx, ax squared plus bx plus c equals zero. Unless if you're solving by square roots, which I'll show an example of towards the end of this video. But if you're going to factor or if you're going to use the quadratic formula, it needs to be set equal to zero. Okay, so factoring, right? A is equal to 1. So last video, so what multiplies the 38 adds 21? 38, 6, not 16. 16 and 2, no. Oh, 19 and 2. 19, positive 19, positive 2. All right, so we get plus 19 plus 2. So there's a zero product property, and the zero product property is if you multiply anything by 0, it becomes 0. 0 times anything is 0. So if I want this to be equal to 0, all I need to do is plug in an x value that will make one of them equal to 0. So what x value do I plug in to make that 0? Negative 19. What x value do I plug into this one to make 0? Negative 2, right? Negative 2 plus 2, 0. Those are my answers. Those are my solutions. If I plug in negative 2, I will get 0. If I plug in negative 19, I will get 0 because I'll get 0 here, and 0 times this is 0 because 0 times anything is 0. And remember, the solutions are also the x-intercepts. So that means that on a graph, right, I would have an x-intercept at negative 2, and I'd have an x-intercept at negative 19. I don't know why I'm putting 12, negative 19. And this is positive, so it'd be going down something somewhere, I don't know. Right, so you get your parabola. So the solutions are the x-intercepts. Moving on past that, let's just breeze through some more stuff. So here's one with the GCF, greatest common factor. Now the difference between last time, in the last video and this video, is the last video we were factoring. Now we're solving. So instead of dividing the 2 to sit out here, or I should say more like sit out here, we're not going to put the 2 out there. We don't need to do that, right? We do not need to do that because we can just divide. Now that we have an equation, we can divide both sides by 2 and just get rid of it. Because what's 0 divided by 2? 0. So we can just divide everything by 2. 2 divided by 2, 1x squared. Negative 6 divided by 2, negative 3, negative 8 divided by 2, negative 4, 0 divided by 2, 0. So when you're solving, it's a little bit easier to get rid of a GCF because you just divide everything. Instead of factoring out the greatest common factor, you just divide everything by the greatest common factor, and 0 divided by the greatest common factor is 0, and everything else gets simplified. Anyways, now we got that. So we got the C value and the B value. So this is actually copy and pasted from the other problem. So we factored this in the first video. So you get negative 4, positive 1, so minus 4, plus 1. So what do I plug into this one to get 0? Positive 4. And what do I plug into this one to get 0? Negative 1. And again, the order doesn't matter. You could have did x plus 1 and x minus 4, and this could be -1 here, and this could be +4 there. It does not matter. All right, does not matter. Okay, so we got the AC method. So now we're going to solve using the AC method. There is no GCF, right? There's no GCF. I can't, 17 is a prime number. 17 is a prime number. The only thing that goes into 17 is one and itself. Okay, so AC method, what is 4 times 4? We get 16, and we got -17 down here. So remember, when you got a positive number up top, a positive product, and a negative sum, both numbers have to be negative. And I'm going to say -16 and -1, because those multiplied together give you +16, and those added together give you -16. So in the last video, I didn't flip it up or switch it up. So in this one, I am going to. So I'm actually going to put -1 here and -16 here, just to show what I did not in the last video is that it still works. So we get -1. We're going to group. We get -16x there. Group it up. So what's the greatest common factor here? Well, I have a 1 there, so nothing goes into 1 other than 1. At least no whole numbers. So the greatest common factor is just an x. So I'm going to get 4x minus 1. Greatest common factor here is, well, remember, I don't want the leading term to be negative, so I'm going to factor out a negative. And then 4, because 4 goes into 4 and 4 goes into -16. So I'm going to divide out a -4. So what is -16 divided by -4? +4. X. And then what is 4 divided by -4? -1. And just like last time, all right, you get this and this, which I'm going to put right there. So I get 4x minus 1 there, x minus 4 here. Oh, I switched those up. I didn't match my blue and black lines. The blue was supposed to go here and the black was supposed to go there. But again, it does not matter. It does not matter. I didn't leave myself enough room here. So I'm going to add in this step. Now, you don't necessarily need to do this step, especially for this one. But the zero product property means is I want to find out what x value I plug into this to make it 0. So I set it equal to 0. This is the step that I was skipping in the other two problems, just because you can visually see it. Like, I already know this answer is 4. But why is it 4? Well, because when I set it equal to 0 and I add 4 across, right, because I want to cancel that out, I get x equals +4. So that would be, zoom out, like I said in the last part, then I'd have to do that eventually. So I would get x equals 4. Here, it's a little more difficult to see. So if I set 4x minus 1 equal to 0, because again, if I make this whole thing 0, 0 times this is 0, because 0 times anything is 0. So get rid of subtraction first. So if you don't remember how to solve equations, which I don't know why you don't know how to do that if you're in quadratics, but you cancel out addition and subtraction first, and you cancel out multiplication, division second. So I'm going to cancel out a subtraction with addition first, right? I do that first. So I get 4x equals 1. Now I'm going to cancel out multiplication, and I'm going to do it with division. So I get 1/4. Also totally fine if you put 0.25. Either of those, fine. What's not fine is if it is a repeating decimal. So like if it's 1/3, put 1/3. Don't put 0.33, because now you've approximated it. All right, do not approximate your answers in Algebra 2 unless the problem says specifically to approximate. So the exact answer for this would be 0.25, but the exact answer for like 1/3 would not be 0.33. That would be an approximate. Okay, got another one. This one also has a GCF. So this is the problem that we did, I think in part 1. So divide everything by 3. You get 15 divided by 3 is 5, negative 27 divided by 3, negative 9, negative 6 divided by 3, negative 2, 0 divided by 3, 0. So I got rid of the greatest common factor. Now I need to use the AC method. So 5 times negative 2, negative 10. Needs to add negative 9. So one of them is going to have to be negative. And we did this in part 1. Negative 10, positive 1. So I'm going to switch this up. So I'm going to go plus 1 here. I'm going to go negative 10 here. So plus 1x minus 10x. Okay, so what can I factor out? What is the greatest common factor here? Well, it's just x. And I get 5x plus 1. Right? The only thing I can factor out is an x and a 1. And I did factor out 1x. I did. I'm just not going to put the 1 in front of it because I don't need to. What can I factor out of this other one? So I can factor out of this one. Well, whatever it is going to have to be negative because I don't want that negative in front. Negative 2. It's the only number that goes into 2 is 2 or 1. So I'm going to factor out negative 2. Negative 10 divided by negative 2 is positive 5x. Negative 2 divided by negative 2 is positive 1. And there we go. We get x minus 2. And we get 5x plus 1. Now I am going to skip this because I don't need to do that. I can just see that it's 2. All right, you don't have to do that step if you don't need to. I know that 2 minus 2, if I plug in a 2 right here, I know that 2 minus 2 is 0. I don't need to solve for that. And that's the goal. That'd be my goal, that definitely that you can visualize that in your head. Here, though, a little bit trickier. So we got 5x plus 1. How do I get rid of addition? I subtract. So we get 5x equals negative 1. How do I get rid of multiplication? I'm going to divide. I get x equals negative 1/5. So negative 1/5 is a perfect decimal, and it would be negative 0.2. All right. Totally fine if you leave it as negative 1/5 too. That's an acceptable answer as well. Acceptable answer as well. Okay. I think, yeah, okay. Now we're going to move away from solving graphically. So a really important thing, especially because the quadratic formula has a square root in it, which is the whole reason why solutions are called roots as well. From part 1, I showed the 4 different things. You can call a solution, an x-intercept, a 0, or a root. And that's because we take the square roots. They're roots. Solve a cubic, you get a cube root. So here's how, so something you need to know how to do is you need to know how to simplify a square root. Usually this is taught definitely in geometry when doing special right triangles and simplifying even the distance formula, finding distance exactly. So square roots, how to simplify them. Well, something you're going to want to remember is at least up to 10. And we don't care about 1 because dividing things by 1 doesn't really help. So we start with 2. So 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. 10 squared equals 100. 11 squared equals 121. What else do I know? We got 12 squared equals 144. 13 squared, I think, is where I start to not remember. I want to say it's 169. And I would have been correct. I want to say 14 squared is like 192 or 196. 196. And then 15 squared equals 225. Double check that one too. Yeah. So, I mean, that's usually the general ones. If you take like pre-cal or something, you probably remember up to 20 squared. But what you're going to want to remember from here is when simplifying square roots, the numbers you're going to want to divide by aren't these numbers. The numbers you're going to want to divide out, like you see there, I divided a 4 out. I factored 20 into 4 times 5 is because 4 is a perfect square. So these are the numbers that you want to see if they divide or can be factored out of what's inside the square root. Because then when you do, you can take the square root, right? So if I divide 20, or I factor 20 into 4 and 5, 4 times 5, I can now separate this square root into 2 separate square roots. And the whole purpose of that is we know what the square root of 4 is. The square root of 4 is 2. So it just becomes 2/5. And then here I show you that there's long ways and short ways to do this. So if you have a list like this next to you, you can usually find the quickest way. You can find the biggest number. And the biggest number that goes into 500, that is a perfect square, is 100. That's the biggest number that goes into 500 that is a perfect square. So if you start with the biggest number, you'll solve it more quickly. You'll simplify it more quickly. So 100 times 5, square root of 100 is 10, so I'll get 10 square roots of 5. Okay, you're not dividing out a 10, you're dividing out 100, or actually you're dividing out a square root of 100, and the square root of 100 is just 10. Not the square root of 10, the square root of 100 is 10. All right? So here's a longer way of doing it. Let's say if you're somebody who can't immediately see that, it's okay. There's more than one way to do that. So 25, most people, 500 is $5. So a quarters go into $5 perfectly. So divide 25, that means 20 quarters. So the square root of 25 is 5, and I get 5 square roots of 20. However, the square root of 20 is not simplified yet. So the square root of 20 can be broken down to, like we just did, can be broken straight down into 2 square roots of 5, which happens here. And then what's 5 times 2? 10. So you can get the same answer. There's just shorter ways to do it. And the shortest way is to find the biggest number. But if you don't see the biggest number, that's fine. There's more than one way to do it. So let's go through some of these examples. So solving this quadratic isn't in standard form. And I'll say the quickest way to solve a quadratic when there's no, so if we have ax squared plus bx plus c, if this term is not there, then the quickest way to solve it is using square roots. If the term bx is not there, if there's not an x variable, just an x variable, not an x squared, but if there's not an x variable, the quickest way to solve it is using square roots. So I want to get x squared by itself, so I add 20 to both sides. I get the square, or x squared equals 45, which is down here. I don't know why I gave so much room in between there. But you get 45 here. All right, and then what's the inverse of squaring something? Taking the square root of it. Now, whenever you take the square root, you get plus or minus, because negative times a negative is a positive. All right, and a positive times a positive is a positive. So you get the plus or the minus. So 4,500 here. And that cancels that out. So I get 45. Now we can simplify this. So the biggest square root, perfect square, that goes into this. Does 4 go into 45? No. Does 16 go into 45? No. Does 9 go into 45? Yes. 9 has a square root. 9 goes into 45 5 times. 9 times 5, 45. What is the square root of 9? 3. And this is done because I can't simplify this anymore. This is my answer, right? My answer is x equals plus or minus plus, doesn't matter, 3 square roots of 5. That's it. That's done. All right. So let's go through a couple more examples. Solving quadratics doing this. So this one doesn't look the same, right? There's no x squared. There is. This one's kind of in vertex form a little bit, right? This would be x minus h in here. It's also in factored form. I don't know, however you want to look at it. So it's actually vertex form. It's in vertex form. So how could we go about this? Well, this whole thing, I want to make this very clear that if this was x squared plus 5 equals 25, you can't just take the square root of this whole thing. I mean, you could, it wouldn't help. And why you can't do that, or why you shouldn't do that, is this term, or this whole thing, isn't being squared. The only thing that's being squared here is the x squared. Here, though, all of this is being squared. So when you take the square root of the whole thing, it's going to cancel that out and leave what's left on the inside. Right? So if I was doing this problem, I would subtract 5 first and get x squared equals 20 and then take the square root. Right? That's when I would take the square root, after I move the 5 across. But here, PEMDAS, exponents, and then parentheses, I need to cancel out this exponent so that I can get what's on the inside of the parentheses out. So whenever you're solving an equation, you're kind of undoing it. You're doing PEMDAS backwards. So before I can do inside the parentheses, I need to cancel out the exponent, right? If I do PEMDAS, and I might be over-explaining, I mean, I'm sure I am over-explaining this, but you cancel this way, right, when you're solving. So I have to cancel out this first, and then this. So this is first, and then this is second, at least in this problem. It actually first, second, or no. First, second, third, fourth. So I had to cancel that out first because of the whole thing. All right, anyways, over explained it. So we get the square root of 25. The whole point of this is that crosses out, cancels out. You don't have to square anymore. You get what's on the inside of the parentheses out because you canceled out the exponent. Square root of 25. Still got the square root of 25. No, I don't. I don't know why I'm doing that. We all know what the square root of 25 is, yes? Hopefully. Square root of 25, that one's a simple one. It's 5. And I'm going to make this into a 5 somehow. No, I'm not. I'm just going to scribble it out. You get a 5. I obviously need to end this video here pretty soon. So you get a 5. So you got plus or minus 5. So plus or minus 5. And this minus 5. Why is this minus 5 over here? Well, how do you get rid of addition? You subtract. So I got plus or minus or plus 5 minus 5. Well, this is two different answers. This is two different numbers. So how I usually break it out is I go, what is negative 5 minus 5? Negative 10. What is positive 5 minus 5? 0. Well, I butchered that problem. So let's not butcher this next problem. So we got the same thing here, except if I'm doing PEMDAS backwards, I actually have, I don't have any subtraction, but I actually have some addition to cancel out first. So minus 7, and I get 40. All right, cancel that out now. There's no division to happen. There's nothing being multiplied on the outside. There's nothing happening there. Now I get to the exponent. I need to cancel that out. So how do I cancel that out? Well, I take the square root, right? So I get the square root of both sides, 40. That cancels out. I just get, right, just cancel that out. So I get x minus 5, which is on the inside of the parentheses, equals what? So 40. What goes into 40 that has a square root? What's a perfect square? I'm going to say 4. 4 and 10. So 4 and 10. What is the square root of 4? It is 4. Just drop your x minus 5 because you didn't touch it yet. 10 in there. 10, you can't do anything more with the square root of 10. Can't do anything more with it. Okay, so that's actually simplified as much as we're going to get. Now, if you use the calculator, you're going to get decimals, but we don't want decimals. We want the perfect, exact, not estimated value. So this is what we're going to leave it as. How do we get rid of subtraction, though? Because we're not done solving for x. How do we get rid of subtraction? With addition. Okay, now what's really important here is you cannot, without using a calculator and estimating, you cannot combine those. Okay, you cannot combine those. So how we're going to write this is we're going to put the whole number in front, and then we'll just have plus or minus 4 square roots of 10. All right, that would be your answer. You would just type that in. Write that in on your paper, whatever it is. That would be the final answer. Now, if you're trying to graph this, like if you're trying to find the solutions and graph it and stuff, then I would say use a calculator, get your decimals, and then estimate using those decimals where the x-intercepts would be. Because obviously, I don't know how to graph square roots of 10. I don't know anybody who knows that perfectly. So you just use your calculator and approximate it. But if you're doing some homework and you're trying to find exact answers and it just says solve it, this is a solution. I feel like any math teacher would accept this. 4 square roots of 10. All right. So is that the last one? I feel like that. Yep, that was the last one. Thank you for watching part 2. Part 3 is going to get into imaginary numbers, complex numbers, quadratic formula. So hopefully that video is helpful also. And I'm going to tune out. So thank you for watching. I hope this video was helpful.